Okay, so recently I saw this problem in a Tom Crawford video and I thought it was really nice, so I watched the video and attempted the problem myself, and I'm just going to show you basically what my solution to like a variation of the question would be. So in the question you have this sort of like, it's defined like a chessboard where you have this grid-like formation where alternating squares are black and white. So like you have black square and then white square in like a diagonal pattern like this, and it's n by n. And then you have all these Tetris pieces, so all the possible Tetris pieces, and you have to figure out how many sets of all the Tetris pieces you would need to fill this chess-like board that you have. Okay, the first thing we need to do with this problem is to figure out all the variations of Tetris pieces that you have, and for this there are 7, so I'm just going to draw all of them out really quick. Okay, so these are the pieces you have, and the first thing that you need to notice about all these pieces is that if you were to arrange them on a chessboard, 6 of these pieces would have 2 of their squares covering dark squares and the other 2 covering light squares. Like this. It doesn't matter which is dark and which is light to you, but the other piece that you have here, you would have 1 color covering 1 color square and 3 covering the other colored square. Okay, so looking at these first 6 pieces, you can tell that this will cover 24 squares, because each covers 4, and so you have, if you have k sets, then these will cover 24 k squares, and then you just have k lots of this, which will end up being your main problem. Okay, next you're going to look at the area of the square, which, since it's n by n, the area will be n squared. And notice how it has to be a square. So your area is equal to k sets of the 7 pieces, which each cover 4 squares, so that's 28k. And since this has to be a square, k is going to be 7 times this m squared, where m is a member of the natural numbers. Since 4 is 2 squared and 7 is not a square, so in order to be a square it would have to be a multiple of 7 and then any other square, which could be 1. Okay, so first looking at the case where m is 1, k is equal to 7, so you have 7 sets of all of these pieces. Now the area of those pieces is going to be 7 times 28, which is 196. So the board is going to be 14 by 14. Now if you take from earlier the 6 pieces that fill these squares evenly, so as in they fill 2 black squares and 2 white squares, no matter how you orientate them. If you were to take your 28 sets of those 6 Tetris pieces and place them on the grid, they would cover an equal number of black and white squares, and the total number of squares they would cover would be 24 lots of 28. Oops, sorry. No, 6 lots. Yeah. Yeah, 6 lots of 28. Which means that you have 28 squares remaining. And this is split into 14 black squares and 14 white squares. Okay, if you consider this piece has 2 variations, where one covers 3 black and 1 white square, and the other covers 3 white and 1 black square, and in total you needed to cover 14 black and 14 white squares. You can try in any way that you want to orientate this, where you get these 7 of either of these pieces to equal that, and it's just not possible. So equaling 1 isn't a solution. Okay, next you consider when m is equal to 2, you have that n squared is equal to 28 times 28, because it's 7 times 2 squared, which is 4. 7 times 4 is 28. So you have this 28 by 28 board, and if you consider the first 6 pieces, which are, I'm calling them even because they cover the same number of black and white squares. If you consider these, they will cover 28 lots of, because k from this you get is 28. This is your value of k. So it covers k lots of, each square has 4 and there's 6 of them. So it covers 6 times 4 times 28, or 24 times 28 of the squares, which means that your remaining awkward piece will have 4 times 28 squares to cover, with half of this, so 56 being black and 56 being white. Oop. Okay, now you're going to consider, oh, there's a spider on my wall, that was quite cool. Anyway, you're going to consider the 2 possibilities of this piece covering 3 black and 1 white, and 3 white and 1 black. And if you were to combine these 2, you have, from the question, you have 28 lots of these in total, by the way. If you were to combine these 2, then you would have 4 black and 4 white pieces. You can make 14 sets of this, so if you do 14 times a 4 black and 4 white, you get 56 black and 56 white, which means that they would cover the right squares as long as it fits on the board. So now your only problem is discovering a solution where it fills every square on the board without ever, like, well, there can't be any overlap because that just wouldn't fill all the squares, but you need to actually find a possibility to prove this, so we're going to do that now.
It was you and me, that's the only place that I know I would like to be, cause I think I need a picture, cause it's never enough to see you.